Hi everybody, this is Mr. Weber. Today we're going to talk about 2.1 notes. This is our intro to slope, the first section in chapter 2. Now some of this might be review for a lot of you guys, but it's super important that we get the basics down of slope so we can apply it to more complex things later in chapter 2. So please follow along with me. Make sure you write everything that I write down in your note packet with me today. Okay, so first, rate of change. This is a ratio that shows how one variable changes with respect to another. In other words, on a linear graph, this is called the slope of the line. So slope is written as a ratio of the vertical change, and we always call the vertical change our rise, to the horizontal change or our run between any 2 points on a line. This slope always remains constant for any 2 points on the same line. Slope is written as a fraction in simplest form. The variable for slope is always m, and we will get to that later. Okay, our different types of slope. So we're going to draw a line in here. Looks about like that. So if I drew in an XY axis here, here's my Y, and here is my X. This red line shows a positive slope. That means the value of the slope will be a positive number or a positive fraction. Another XY axis here. If I drew in a line that looked like this red line, this would have a negative slope. The rise over run would give us a negative value, so -3 or -1/2, for example. If I had a perfectly horizontal line, we would call this slope 0. And then finally, if we had a perfect vertical line here, this slope would be undefined. Those are all the different types of slope that we can have: positive, negative, 0, and undefined. Okay, finding slope on a graph. Remember, m is always rise over run. So number 1, we're going to find the slope of each line, and then we're going to write our answer in simplest form. So in all these boxes, we have 2 dots that are shown. We have a dot here that's marked in black. I'll just write over it, and a dot here that's marked in black. We simply count our rise over run between these 2 dots. So if I start at the bottom dot, I rise 1, 2, 3, 4, 5, 6, 7. I rise 7, and I would run 1, 2, 3, 4. I would run 4. So the slope of this line would be rise over run 7/4. We're going to do the same thing for number 2. Here is the 2 dots that are given. We have one in this corner and the other right here. Now notice that this line has a different type of slope. We would call this type of slope, it has a negative slope. So our final answer, a fraction, should be negative. So we're going to count our rise over run. Again, I'm going to start at the top left box, and I'm going to have to go down this time. So down 1, 2, 3. And if I go down, that gives us a negative value. So we're going down 3. And to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9. So our rise was -3. We didn't actually rise, we went down, so that gives us that negative value. But our run to the right was still 9, a positive 9. So we have -3/9, which can reduce to -1/3. And that is the slope of that line. So that means if I apply that slope of negative 1/3 from this same dot up top, I go down 1. That's a negative 1 over 1, 2, 3, and that should intersect at a corner of our XY axis there. So it intersects exactly at that coordinate point. If I continued it down 1 over 1, 2, 3, I cross exactly at another point in our line. If I continue down one more, down 1 over 1, 2, 3, I hit that final point. So remember, our slope can be going on forever and ever and ever with these arrows at the end of the line. So we can continue our slope as long as we need, up to the left and down to the right. Let's do number 3. Number 3 looks a little different now. So our 2 dots are here and here. We still count our rise over run, even though it looks different. So we don't rise any. So we're going to say we rise 0, but we run to the right 1, 2, 3, 4. We run 4. So we can still put that in our rise over run for our fraction. So we rise 0, we run 4, but what is 0 divided by 4? It is 0. So any horizontal line, the slope is always 0. That's exactly what we had here. Any horizontal line, it's 0. There's an example of how that comes out. Okay, number 4. Again, we have a vertical line. Here are our 2 dots that we're going to count our rise and our run. So if I start at the bottom dot, I rise 1, 2, 3, 4, 5. I rise 5, but do I run left or right any? No, we run 0. So we still put that into a fraction. We rise 5, we run 0. So 5 divided by 0. What happens when we try to divide by 0 in our calculator? It gives us an error. This is why we say any vertical line, the slope is undefined. Okay, moving on to the next page. Let's jump down. We're going to skip some of these, and you guys, if you have time today after these notes, I want you to fill in the rest of these that we are skipping, but we're going to skip down to number 14. Let's figure out the slope of 14. So right away, we can already identify whether it has a positive, a negative, or a 0, or an undefined slope. So here, what do we think we have? Here we have a negative slope. So already, we know that our slope has to be a negative number. So we check our 2 dots. Here's our 2 dots. I always like to start at the top dot, so the one that is at the highest. So I'm going to start here, and I count our rise, but we don't actually rise. We go down 1, 2, so that gives us a negative value. I went down, so I put it as a negative 2, but I still run to the right. I run 1, 2, 3, 4. So our rise over our run would equal negative 2 over 4. But can we reduce negative 2 over 4? Yeah, we absolutely can. That will give us a negative 1/2. There's our slope for number 14. Okay, once again, I want you guys to fill in all of these that we have not done yet when I'm done with the notes video today. But we're going to turn to the next page. This is our 2.1 continued page. We have another page of notes for 2.1. Still our intro to slope though. Now we're going to talk about our slope formula. So the slope formula is used to find the slope between 2 points, x1, y1, and x2, y2. So here is our formula that we will use. Fill this in with me. M is equal to, remember, M always represents our slope. That's always the variable we use for slope. M equals y2 minus y1, and those are subscript 2, subscript 1, divided by an x subscript 2 minus an x subscript 1. There's our formula that we'll use. It is probably a good thing to memorize this formula because we will use it a lot for the rest of this year. Okay, so let's apply this formula to number 1. So we're going to find the slope between each pair of points. So on number 1, I have the point 1, 1, and the point 4, 3. So we have a couple choices. We can graph these 2 points if you like graphing. We can graph them. so we can actually see where our line might be. That is one way to do it. And then we count our rise and our run. But let's say we are not going to graph, so we can apply this slope formula. So when we write ordered pairs, it's always x comma y, right? The first value is x in our parentheses. After the comma is our y value. So for this 1 comma 1, that first 1 would be an x, and the second one would be a y. And we do the same thing for 4 and 3. 4 would be an x, and 3 would be a y. But notice in our slope formula, I have two x's. I have an x2, and we have an x1. We also have a y2 and a y1. So we've already labeled our x's and our y's, but we need to distinguish which one is going to be our x1, y1, and which one is going to be our x2, y2. And it doesn't matter which one we choose. I always just like to pick the first point that comes to be our x subscript 1, our y subscript 1. So I draw them in. And the second point can always be x subscript 2, y subscript 2. So basically all we did was labeled our 2 points here. And now we have them labeled so we can plug them in to this formula exactly where they go. So let's try it. So my formula is m equals our value of y2, which is 3 here, because we labeled it as y2, minus y1. Well, our y1 is 1, divided by x2 minus x1. But here our x2 is 4, and our x1 is 1. Now all we have to do is simplify this, and we get our slope. So we simplify it. 3 minus 1 is 2, and 4 minus 1 is 3. So our slope here is 2/3 using that slope formula. Okay, let's try another one. Let's try number 2. Same type of idea. We're going to use this same slope formula. Here we're given 2 different points. So the first step is to label your 2 points, your x1, y1, and your x2, y2. So I take my first point, and I always label it x1, y1. So -2 is x1, 4 is y1, and your second point will be x2, y2. So 10 is x2, and -2 is y2. All we have to do is label them correctly, and then we can plug them into the slope formula. So our slope formula is y2 minus y1. Our y2 value here is -2, minus our y1 value, which is 4, divided by our x2 value, which is 10, minus our x1 value, which is a -2. Notice I put that -2 in parentheses because our formula always subtracts y2 or y1 from y2 and subtracts x1 from x2. Always have a subtraction sign there. So all we have to do is simplify this, and we get our slope. So at the top, the numerator is -2 minus 4 gives us what? -6. In the bottom, a 10 minus a -2. What happens when we subtract a number? We go in here and say, oh, 2 negative signs right next to each other. I go slash, slash. Oh, yeah, we're adding. So 10 plus 2 is 12. So our slope is -6/12, but we always check if we can reduce that or not. Can we reduce it? Yeah, we absolutely can. This will give us a -1/2 as our slope. We are going to skip 3 and 4, and we are going to jump down to number 5. Same type of idea. First step is to label your x1, y1, and x2, y2. Again, I pick the first set of, or the first point, 5, 9, to be the x1, y1, and the second point, 3, 9, to be your x2, y2. Always label first, because when we have it labeled, it's really easy just to plug those numbers in to our formula. So m is equal to our slope formula. I have to go back up here and remember what it looks like. y2 minus y1. So here our y2 value is 9 minus y1 value, which is 9, divided by x2 here, which is 3, minus our x1, which is 5. So we simplify this. 9 minus 9 is 0. Over 3 minus 5 is -2. But what is 0 over -2? That gives us a slope of 0. That means our line will be horizontal. Whenever we have a slope of 0, our line will be perfectly horizontal. Let's jump over and do number 6. Same idea. We have 2 points here, -7 and 8, and -7 and 5. We label our 2 points. So the first point that we see, we label it as x1, y1. The second point we see, we label it as x2, y2. And then we plug into our slope formula. So m equals y2 minus y1. So it's 5 minus 8 over x2 minus x1. So here x2 is -7 minus a -7. So -7 minus, I'm subtracting a negative number, so I'm going to put it in parentheses. And we simplify this. 5 minus 8 is -3. But here on the bottom, I have -7 minus a -7. Whenever we see those subtraction signs right next to it, we come in here and go slash, slash. Oh, yeah, we're adding. So -7 plus 7 gives us 0. So -3 divided by 0. Can we ever divide any number by 0? No, we cannot. So this would be our undefined slope. And when we have an undefined slope, that means our line will be vertical, perfectly vertical on a graph if we were to graph it. Again, when we are done with the notes today, I want you guys to do 3 and 4, 7, 8, 9, 10, and 11, and 12. All the examples on this note page that I did not do. But we're going to jump down to the second page here, last page. And we're going to think about this going backwards. So sometimes you must complete the ordered pairs using a given slope. Example, if the slope of the line passing through the points -5, 6 and 5, y is -4/5, we are going to find y. So we have our 2 points here. We have -5, 6 and 5, y. We are still going to plug in to our slope formula. And remember, our slope formula is m equals y2 minus y1 over x2 minus x1. But here we already know what our value of m is. Our value of m was given to us. It's -4/5. So we're going to start with that. So -4/5, our value of m is equal to, now we need to fill in everything that is left here so we can solve for one of those y's. So let's label these 2 points just like we did in these last few examples. So I take the first point I see, -5, 6. I label it x1, y1. And the second point I see, x2, y2. Even though that y2 is a variable y, we're going to solve for it. And we plug in to our slope formula. So our value of y2 is actually just y. So we leave it as y. We're going to solve for that y. Minus our value of y1. What's our value of y1? It's right here. It is 6. Over x2 minus x1. x2 is 5. x2 is right here. And x1 is -5. So 5 minus a -5. And we are going to solve here. So is there anything we can simplify to start? Yeah, absolutely. We can simplify this bottom. So this will become -4/5 is equal to y minus 6. Can't combine those because they're not like terms. But the bottom, 5 minus a -5, again, we come through and go slash, slash. So we add them. 5 plus 5 is 10. Now we're at this point. We have to solve for that value of y. And how do we do that? Well, we're going to think back to how we solve equations just like we did in chapter 1. So I have to isolate this y value. I have a subtraction by 6 attached to it and a division by 10. So I want to get rid of that division by 10 first. So the opposite of dividing by 10 is multiplying by 10. And what we do to one side, we will do to the other. So I'm going to multiply this -4/5 by 10 as well. So when I multiply the right-hand side by 10, these cancel. I'm left with y minus 6 on the right. But if I'm looking at the left, I have 10 times negative 4/5. This becomes 10 over 1 times negative 4 over 5. When we multiply fractions, we multiply the numerators and we multiply the denominators. So 10 times the negative 4 is negative 40, but the denominator is 1 times 5 is 5. And can we reduce this negative 40 divided by 5? Absolutely, we can. What does that give us? That gives us a negative 8. So this left-hand side becomes negative 8. Now we have a one-step equation to solve for y. What's still attached to the y? I have a subtraction by 6 attached to the y. What's the opposite of subtracting 6? We add 6 to both sides, draw our bar underneath, and then we go column by column. So this column on the left, negative 8 plus 6, that will give us a value of negative 2. Bring down your equal sign, bring down your y, and negative 6 plus 6, those cancel. So our y value, our final answer, is negative 2. It's a little bit more work there, but we're still using our slope formula to find a missing piece of those coordinates. So I want you guys to try the rest of these today. You have plenty of examples on all the ones we did today. If you need to pause the video or go back, that is absolutely fine. But fill in any example that we did not do on the note. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 16 on that first page. And then on 2.1, continue. Do 3 and 4, 7, 8, 9, 10, 11, and 12, and then the bottom here. Your quiz next class will look exactly like the examples that we did today in these notes. Remember, there is recommended homework on the next page for you to try if you would like some extra help. Thank you, guys.